Hello, good morning, good afternoon, and good evening. We're live streaming from our headquarters in Untitled, and today we're focusing on our Datron Next machine control. I'm here in a silence working area. That means behind me are part of our software team working and further developing the Datron Next machine control. The machine control is not a new issue for Datron. We've been developing machine controls since 1988 when we first sold our milling machine M1. Today we would like to give you an overview of the Datron Next machine control. My colleagues are already gearing up over at the Tech Academy, and they would like to show you as newcomers or maybe also experienced machinists how the Datron Next control can be a benefit for you. Just a few words on how today's session is going to pull through. While the colleagues Benjamin and Mark are explaining Datron Next and showing you the ins and outs, you have the opportunity to put in your questions in our chat box, and we will collectively answer all questions after the show. So I pass the word to my colleagues and enjoy.
Next digital experience session. My name is Mark, and on my side is Benny.
Yeah.
Can you just
Hello.
tell us a little bit about yourself?
Okay. My role at Datron is I'm one of the main
Developers.
developer and concept engineers of the Next Control, and this is my doing the last 5, 6 years, 7 years since so.
And that's what we're going to talk about today. The Next Control, the innovative machine control for Datron machines. So you might have seen it before, either on exhibitions or online, but we want to like wrap up it again to show you all the things, the workflow of the Datron Next Control, and it's kind of a hybrid thing today. So we have some clips that we're going to show you that explain, like I said, the workflow and some software options. And in between, we're going to discuss a little bit how did it all start, and what's the future about it? What's like the next development stages? And at the end, we have a super exciting interview with one of our customers from Belgium, company Salvoon. They're making keyboards and keycaps out of metal. So that's going to be very exciting. So let's just start with the clip of where we explain the Datron Next workflow.
At first I want to start by taking a look on the screen here. This is the start screen, the home screen, and at first I want to show you which parts we have here. So on the top we have here just the main points that you can use, that you have to use for the normal program, for the normal working on the machine. So that means program management, tool management, and also the workpiece setup. Here in the middle we have the machine, so the informations of the machine, X positions, also the status of the machine. Also here on the bottom we have just the programming part, so the editor, and also the manual operation that you can use for just a single hole or doing some easy things. On the bottom here we have just the technology buttons, so I would say here is the parking position, unlock door, and also to set up the vacuum. But first we want to take a look on these parts. So this is the main points that you have to use before you starting your machine. So at first we take a look on the program management. So that means that you have to load a program before you start the working on the machine. So that means if you have to tap here on your program, and then you can see also some buttons. On the right side, load program, so there you can also load it. Then we have edit and delete, so if you have to do something with the program, change something or delete it, if it's wrong. The next step you can do is also here, so that means that you check your tools, and you can do this by tapping this button. Then you can see which tools do you have programmed, and which tools are inside in the machine and which one you have to do inside the machine. So we see here we have just one in the machine. So this is this one, and we have just here one that is not in the machine. So this is a promo screen. We do this later with Mark also on our machine. So what we want to take a look at second is the tool management. You don't have to use, or you must use the tool check by the program. You also can check your tools by the tool management button. So here you can see all the tools that is there inside of the machine. But also you have here the Datron tool catalog that you can find every tool, and also can take a look. So if we tap here just by also a single flute, and then we can see here a lot of informations about the tools, and also we can say set up these tools inside of the machine or the tool management. And next we want to see the workpiece setup, and for this I would say I give back to you, Mark.
Right, so once we've loaded the program, like everything is either in our network folder or like directly on the machine's hard drive, you just clamp your part. In this case, I just have a 3mm aluminum plate. I put that on my vacuum bed, switch the pump on the vacuum pump, so work holding is just by vacuum. And in this next step, that's what the software makes it so special. It's measuring the origin, the orientation in that entire machine with a camera, with a live view, just by like swiping over the display and then just drawing a different shape around the part, whatever it is. So let me show you this. You go to workpiece setup up here, and now I got a live view because there is a camera right on the z-axis. So if I just drag over here, the machine moves, and if we let me get a little bit out of the way, I keep just dragging around, and you see the machine just follows where my finger goes. So what I do now is I place my part visually in the center of my machine, and all I do now in the next step is drawing around like a rectangle shape. It doesn't have to be super perfect. And you can see it already brings in some measuring points. And after hitting probe, the 3D probe will come and touch off this part, so it is perfectly located not only in X, Y, and Z direction, but also in rotation. So it's also getting the right angle if it's like a little bit like shifted and rotated around some axis, which is a big thing when it comes to like a two-side operation, and you want the first side to match with the second, or a second with the first. So that is an extremely important function to have, and you don't have to deal with like hard stops, with like mechanical stops, and using dial gauges to bring the part like perfectly aligned to the machine system. So that's it. All I did now is working like swiping over a little bit on the over the display, and my 0 point is all set. Again, I go to my program management, just what Mario said before. I load the file. I got my preview here, and I'm just saying one execution there and hitting the play button. So now the machine goes to the back, grabs a new tool, like the first tool which is programmed in this program, and starts to work on this aluminum plate. So there's nothing special on this part like to see now. It runs for like a minute or so. So pretty straightforward. We're cutting something out on the vacuum table. We're going 3/10 deeper than the actual stock size. And then just taking the part with very clean edges right out of the machine. Simply a great way of setting up workpieces, of setting up CNC programs. So Benny, can you tell us a little bit about the whole development stages. So where did it all start and what was the idea behind?
Okay. It's a little bit Datron specific way we gone with this control. In the past, we make own CNC control of the scratch. It's called the HSC Pro. Most of you know them. And it is now 30 years old. And we spoke about the age. In this kind, we have a console UI, we have MS-DOS and things like this. And this is the age of the old control. And at one time, we thought about the future of the controls. Make or buy, again, this question. And we say, okay, the Datron way is again, make it by your own, bring your own features inside the control and make it off the scratch again. Yeah, and that was the first steps for it. Yeah.
Yeah, and really, yeah, it was always with the idea behind of having a smartphone, a tablet at that time. So make it as user friendly as possible, especially in times where you have less trained staff on the machines, less operators that know the entire world of machining. Yeah. So correct me if I'm wrong, but having someone at the machine that doesn't need a lot of training to like start the machine, to run parts, that was one of the key goals.
One of the ideas was to make it a good visual feedback, making the user control like a smartphone thing, simplify some ways where in the past real numerical stuff, set up a workpiece and things like this, a programming language that a normal human can read, not only machines, like the more cryptic G-code style stuff. And this are one of the main ideas to make the last steps at the machine. They're always needed also in the CAM workflow to make it easy as possible for us. Yeah.
So less numbers to type in. What is the future being about? Like the future development of the next software? Yeah. I mean, having the control now for several years means we have like all the basic functions that you need to work from either CAM side or if you want to program directly on the machine. Where are we? What's the direction we're going currently?
Yeah, the interesting thing is that we are now on the market since more or less 5 years, and we are feature ready like the old control in the most things. And now we must think about the future of the control. We must think about the new features and the new things you really need. And we think the new direction is not so much for every consumer, for every application. We go to special tasks and make things easier that you cannot do at other controls. Talking about control with management systems, talking about quality insurance on the machine. We talk about measuring, adapting data, and go more in the region of special applications and find our niche with a customized control.
Yeah. Sounds good. And we're currently adding new functions to the software, to the code, and we've brought you one of the latest features. When we take a look at the code now, here we can see it. So that's my control now, and this is the code down here to that training part, and I can now load pictures into my code, so PNG files, JPEG files, and even make them larger. So in this case, I've just exported a picture of my drawing to that part, brought it into the code, so I don't have to toggle between my drawing, either it's a hard copy or soft copy. I can directly have this in the code, have it, where is my next step to go, where do I have to program it? And this could be something that is really interesting for everyone who's like having like different fixtures on the machine, different setups that need some sort of a visual feedback. And it's just a great function. Down here, another one that's just an export of the final part of the simulation. That's kind of great. And we also have a file here that displays some mathematic functions. So there's like graphs and other plots down here that comes, for example, from the touch probe. So just as you said, measuring and like validating parts can now be even done in a visual way.
Yeah, that's one of the features we spoke before. It's not only the CAM side way, it's a way of special applications. Mm-hmm. We bring mixed content to the editor, images, graphs, measuring data, statistic stuff, table stuff, and bring it all together for special application. Some of the nice features are if you have molded parts with irregular shapes, you can measure it on the machine, adapt the passes and things like this. And these are the features I think we can make a new approach to complicated application in normal cases and use the flexibility of the new control.
Yeah. Sounds great. But still, we have the features that are available now for a longer time. Great add-ons that save your work holding or make your everyday work a little bit easier. So let's just have a look at the next clip where we explain the different software options. Right, what's next? Software options. So I did this part once now. I made it once. What are our options if we want to make multiple parts of these?
Yeah. So the main thing is when you use multiple parts or you do multiple parts, you have to set up the same like you do just by one part. So that means you have to check your program, you have to check your tools, and also you have to set up your workpiece. What we got to do now before we start the program is here on the play button on the left side, we see this small button here, and we see here the function multiple execution. So if we start this, come on. So we see here these points that we have to take a look on it. So that means that we can have to do all operations with the same tool, firstly by all of our parts. So we save out the tool changing, and so that means that we have to save working time here on this point. It is very easy. We have to set up by a layout, so that means we have an offset in X just by 120, and I will do here in this case just 3 parts more. You also can do this by setting 0 points, but in this case we just do this with a layout. All we have to do now is to save here, and we see here on the simulation here and this that we have just now 3 parts here. And it's very easy. You have to only to do is to set up the multiple execution.
Right, and speaking about the multiple execution is if you have like a big sheet, which camera this is, yeah. If we have a big sheet that you want to get like most part out of it, and so let's say you cut 100 of small parts out of a big sheet, this is 1 meter by 700, so you can do a lot of parts at a time. You want to make sure that tool wear and tool breakage is like observed, that you have, or this machine has an eye on this. And that's why we have the so-called sister tool sister tool option this way. So it will check if there is a certain limit of a path where the tool has gone or a time has expired, or if there is a tool breakage detected just by the tool probe in the back of the machine. So in fact, this means you can set up the same or the like similar tools, same tool type multiple times in your tool magazine, and just keep the machine running. And whenever it detects some like offsets in the length, or like I said, the different times, it will automatically change and just continuing the program. And yeah, you don't have to worry about like changing the tool manually and interrupting the program. Yeah. I have prepared a little demo that I just run in the air now, which will show us if we just keep like we just cut a virtual rectangle now, and we can see down on the screen how the limit, the maximum path that I've set to 1 meter now is like going down, and it's going from green to red. So at the end, the tool is not good anymore. So let's just execute this part. Remaining time is already expired here with the wrong tool. Let me just reset the time again. There we go. I got a maximum of 1 meter, just as I said. And now down here on the status screen, you can see the remaining distance. Let me get on this side here. So on our screen down there, turn the knobs a bit down. It's now getting from green to like red, which tells us like the maximum time is expiring. So for the next part, it would grab a new tool. So yeah, that's a great function in combination with the multiple execution. So if you, there we go. If you utilize the machine with like multiple parts at a time in combination with sister tool management, that gives you like a very stable process, I would say. All right, what else is important to know when it comes to working on the vacuum? What software options would you recommend, especially for vacuum, not only?
Yeah, just not only for a vacuum, but it is a very easy but a very special software function. So that means that we have to save our tool, to save our clamping system. So that we can find here on the workpiece geometry, we see here protecting areas. So that means the protecting areas are to protect your clamping system, and especially the vacuum. So it is there very easy, because we have to set up just an set measurement point and have to set up here the completely machine room for this. And also, but you can do this by using normal clamping system, and also the 4 axis or axis 4. It is also you can use there.
Right. Now, if it comes to parts that are not perfectly flat, just like this one, that you can see it there. I've bended this part like a little bit. It's also another like flat piece of aluminum. I just bended this like it's like an S wave or S-shaped part now. What do you do if you want to have like a constant engraving or just like a constant machining on this? We're going to use the probe for a surface profile. So the surface profile is just, it's like measuring. It's like doing a lot of probing points over the surface of the part, and then compensating the z-axis. Very good for when it comes to like housings, where you have like a little bit of like deflections or from the process before that are just not perfectly even, and that's where you can use the 3D probe to compensate this. And I'm bringing this part now here in my centric vise, and what I'm going to do first is I'm probing the origin again, and after the origin we're doing that measuring field. All right. So again, I'm just dragging over, you see this? Yep. Over this part, we can clearly see our vise here and the part. First again, I'm drawing this L shape, and that's another important thing to know. Like on the part before, I've probed a rectangle, like the center of a rectangle, but in this case we just probe a corner, and there are different cycles possible. So it could be either a round shape like a bore, or like a big pin something, rectangle, corner, edges. So there are multiple options possible. All right, we probe this first, and in the next step, I'm gonna draw a rectangle that gives me multiple probing points over this surface. So I'm going down here to surface profile, still here in my live view, zooming in. So it's extremely easy to use, and you see this is very easy to learn also. And if I then just draw this rectangle, you can see there are multiple points. I'm reducing the rows in Y and doing a few more in the X direction, making sure that I'm not beside my part, and then once again I'm just pressing play, and the machine starts probing this part over multiple in a grid of like 5-10 millimeters, whatever it is. New on the actual software which just came out is that if you want to build in the measuring cycle that you have done with like your finger, You can also just like copy this information and bring it into the code. So if you set a job up and you just want to like start it on the other day, you don't have to do this setup again. You can directly copy the code to the programming, to the actual cutting program, and it will be executed as well. Now here comes the last probing point, and I'm loading another file. This is just a simple engraving that we're gonna do now, and it's going to start doing like a Datron Neo font kind of thing that we engraved now. And once it's done, I'm going to show you how this came out and how this looks if it's like engraved very even. And we're back. Thank you so much for asking questions. You can still ask your questions in the chat box. After the next clip, we're gonna start to answer them. We already got 3-4 questions in, so that's gonna be exciting. The other thing I've talked about before is the interview with one of our customers, Salvoon from Belgium. I was able to make an interview with him last week. Very exciting company, like I said, keycaps and keyboards out of metal, made on different machining centers and a Datron Neo machine. And Peter Jan is having some insights for us about his everyday workshop life. Peter, thank you so much for having a bit of time for us. And I saw your amazing products on online and on your website. So can you just tell us a little bit about your business and your product?
Yes, we make metal mechanical keyboards and keycaps for a quite niche community. And we've recently gotten the Datron. It's been a year now that we have that machine. But we started out with the Haas machines. And kind of, as most people move up to bigger machines, we move to smaller machines. but with a good mindset behind it.
Yeah, so every machine has a specific field of work where you can utilize it, right? So you have a bunch of milling machines. You have 2 Haas and also two big machining centers and the Neo. Is there anything else that you need in your shop, like anodizing?
We don't do anodizing in-house anymore. We did for a while, but we have other machines like tumblers, polishing machines. We recently acquired an enamel filling machine.
All right.
Basically a very large inkjet printer that shoots enamel. But the main machines are definitely the milling machines.
All right. So speaking about your Datron Neo, what kind of products are you making on it? Is it the caps itself, or is it more than like framing or other parts?
So we purchased the Neo, and our purchase decision for the Neo was made on the switch plates, which is a flat piece of metal with a lot of holes in it that you put the switches into. And with the Neo vacuum table, we thought that was an ideal fit for that kind of work. And as we got the machine, and as long as time went on, we've just added more and more work to the machine that we've been pulling off the other machines, and it proves that it's really great at those things. For example, we used to make keycaps on the VF2, which is over there. Then we moved into the UMC, which half the cycle time. Yeah. And then we moved into the Datron now, which half the cycle time again.
Oh wow!
So it's considerable what it does, and we actually didn't expect that the Neo would be so capable.
Yeah, and I think you can definitely take a big advantage of the high RPM, I assume.
Yeah, totally. But smaller tooling, high RPM, or unbelievable.
But in your eyes, what is the the biggest advantage compared to like other machining centers, also from the software end? So this session is all about Datron Next. So what does it make the machine so special? Is it like setting it up? Is it like the entire interface?
I think it's definitely a combination of the entire package, like hardware and software wise. Hardware wise, the vacuum table and the vacuum work holding is amazing, and there's nothing compared to it. On the software side, it's super intuitive to use. Compared to the Haas machines, like I don't work by myself anymore. I have now someone employed here, and getting him to learn the Haas control versus the next control was the difference between a week to 1 day.
Okay.
He basically, a day in, he could figure out how to change work offset, pick a new program, make sure the tools are fine, and run the machine.
Sounds great. So yeah, thank you for this insight of your business, Peter. I'm really excited always to see your posts online and your new stuff. Super exciting to see what can be done, and yeah, it's definitely a niche. So thank you very much. Stay safe and talk soon to you. Right.
You too. Thank you very much.
Great company, great applications. Thanks again for this interview. So let's talk about your questions. Thanks for asking again. First question was, is it possible to see tool life in the screen? Yes, it is. Can we just see the live screen again in our picture? Then we can just display this right here. Hold on, we just have little problems. Guys? Oh, Simon? Can we just see the team viewer, please? Right. So I am now in my active tool that is in the spindle. I get a warning if I want to edit it. And down here I have tool live service. And I think it was mentioned in in one clip of the software options before. You can set limits. So whenever I set a limit of, let's say, 0.05 meters for this tool, and if I now start an operation, so let's just say we want to start a face milling operation here, 200, that looks fine. And if I now go onto my status screen, I need to activate sister tool management, because the idea behind this, it's like counting the time. But if I do use sister tools, I can use the same tool again. So quickly activate this. This is not counting because it's probably there's no sister tool in.
No, the easy answer is it's live, always a problem. Mark, don't set limits for the tool.
Oh,
That was he's missing.
sorry.
currently.
Yeah. Right. You could have told me before.
Yeah,
All right. Now we're making it the right way. So what we have the tool live displayed down here. Now it's current live service saying 1 minute and 8.9 meters, almost 9 meters. So what I said is a tolerance of, let's just say 5 or 15 meters here. And if I now restart my cycle,
And in the end, the tool must be green.
right now
Yeah.
in my right lower corner here, I can see the color changing from green over yellow going to red whenever a tool life is expiring towards the end time. So I think there are like these two values that we can have. We see the actual tool life counting upwards in the tool management, and we see in the status screen the remaining time or distance.
Yeah.
Next question is, how can we set up the height of the XYZ sensor while it measures X and Y side of our piece? It would need to be lower than the default position. So I think the question, to make it clear, is if, let's say this is the side view of your part and my fingertip is the probe, you get the reference on the top surface. And now the question is, how can I go deeper than the default setting, which is 0.5 millimeters? So if you have a larger, like a chamfer, let's just fold this. So now I have a chamfer here, so I need to lower it. I've already put a part on the machine. I go to my camera measurement and make the pre-positioning. So let's just measure this corner. And what I do now is I tip on one on the three measuring points of x and y, measuring vector properties, select all if you want to be like lower on all, or you have them like each individually. And then you go to z offset, and instead of minus 0.5, you can say minus 3. And we don't have a camera inside the machine now. If you just take a step back, Benny, or to my side, now the probe goes a little bit lower than the default. So that would be the easiest way of like avoiding chamfers or coming around.
The interesting thing is with the camera measuring stuff, we have the real easy way for the normal solutions, but you can nearly adjust everything of the feature. 1 point, many points, you can measure a circle, or with a whole circle, or only in a segment of the circle. You have a real freedom. Also, it is so easy to use,
Yeah, correct. And the question that comes up very often is, can we implement the probing into the code? And the clear answer is yes. We can load origins. We can
definitely.
We can load even the measuring profile itself. We can set up measuring or like origin detection cycles and so on.
Yeah. One interesting feature in this region is eventually you can also use this camera-defined measuring feature and paste it right defined from the camera side in your program. It's all possible. You have a lot of freedom to adjust your measuring application. Yeah?
If you have like kind of random numbers, you don't have to type them in manually, etc.
Yep.
Next question, which tolerances does the XYZ sensor have or can measure? So this is a Renishaw probe that we have on that folding arm, which has a tolerance of around 5 microns.
Yeah. The repeatability is less than 5 microns.
Less than 5 microns. In the end, it all comes down to the entire system. What is your, like the temperature in the hall? Do we have like a climated room? Or what is the entire setup? Does even the material grow or shrink? So that comes all into the game when it comes to measuring parts, but the repeatability of the probe is 5 microns.
Yeah.
I'd like to see how tool wear is handled on the next control. How is wear applied when trying to adjust the part size? It would be kind of a little bit too much now to put it like into the code, but in fact there are multiple ways of correcting the tool radius.
Yep.
So like CAM or posted programs that come from CAM systems are either posted in correction that is already calculated in CAM, so you got the corrected tool path, and you can't do anything on the machine. Second option would be like G41, G42, the tool compensation.
Yep.
In this case, I could change my tool diameter. You quickly have TeamViewer. In the diameter section up here. So if I make it larger or smaller, that would be compensated then. But some people want to have tool wear or work with tool wear, which could be like in each direction. So that means our zero line is, or the line that we program is 0, and we want to compensate either more or less.
And for this function, generated a tool center path, and with the possibility of a special command, it's tool compensation called on the Datron control, and then you can tweak the path a little bit in or out, only type in the correction values and not working with the radius of the tool.
With the path correction. That's the command that is called in the software. So depending on the post pro, you can put this into the output. It's a super nice feature because it would allow you to do either like plus or minus positive or negative values. So even if you program a 10 millimeter pocket, you can make it 100 millimeter out of it without having the software complaining about any.
And the other thing, you don't mess your tool library with some adjustment for only this specific part. You can make your adjustment just for this one program. It's also a benefit.
Correct. That is another thing. If you have one tool that's making like 3 different features, and you just want to tweak one of those features, you just make the path correction into this. The other thing is, the same correction in the tool length. And for this we have z-axis offset, z-axis offset, one word, that can then lower or set the entire operation higher for any specific value. Also a very great feature. So in my post-processor settings, I have them every day active and for all programs. So I have like a big chance to modify each and every operation.
On tight tolerances, it's normally
on tight tolerances. So let me quickly check if there's anything else in the chat. Yep, now the page disappeared. I saw something with stock definition. Just takes a second. I can't open my file. Can anyone tell me the question? What was the question about? I can't open the file currently. Was ist die Frage? I got it here. Is it possible to define stock for simulation in G-code programs? Our CAM is only set up for G-code. we had this question earlier in the German session.
Yeah.
Benny.
Currently, we must say sorry. We only implemented it currently in the simple language. There's actually no way to define your stock dimension on a G-code program. That's one of the open features.
I think that it would also mean that the tool, like for a proper simulation, you would also need the tool data in terms of diameter and stuff, so you have a real simulation.
The tool data are not the real problem because if you're simulating some G-code stuff, you take the information from your tool library, if they are defined.
Okay,
But the stock simulation, raw stock, it's currently not supported,
Not supported for this, so
maybe in the future,
Always recommended to have a simple post-pro.
Some room for improvement.
It does work with G-code. You can do like all the tool paths, but you just have more options for modification directly on the machine. You have a better visual feedback and so on, and that's why we have everything set up on this simple language.
In general, I could say G-code is well supported in normal cases, like all the milling operations and the status stuff and M commands and things like this. But the soft features like tool definition and stock definition, it's currently only available if you use the simple code.
Oh, next question. Can path correction and z-axis offset be used in G-code programs?
Yeah.
It can?
It can.
We can mix code,
The interesting thing in this case is we have a G-code interpreter, and you can define nearly any or everything what you want to use it also. It means
you mean the converter?
The converter,
the G-code wrapper.
Yep.
That's the file that kind of converts the G-code into the files that the machine and the software understands.
In the end, every customer is free to adjust specific G commands or M commands to their needs and translate it in a program. It's on the control to the simple commands. And this gives you the freedom also to special commands like Fennec stuff, Haas stuff, or any special or application-specific commands you can map to the simple commands. You have a lot of freedom to do this.
So just to get to the file, it's under machine. The G-code wrapper is
the easiest way is G-code.
Oh, G-code wrapper. Yeah, we have a button down to the.
But currently not connected. Give it a try. The G-code interpreter. Where is it here? G-code. Don't fall. Here's it.
It's under the samples.
Yeah.
Under the sampled files, and there is one section. Yeah, but you're zooming in now.
And maybe you see some of the details here. You see some mappings of G-code 81 and things like this, and map it to a simple specific command.
Either G or M code.
Yeah. Yep. This means you're real free to customize the control to your needs. Yeah. To your kind of G-code flavor. I think so. Yeah.
All right. That's it. Thank you for so many questions. That was really interesting and even more than we expected.
Yeah.
So yeah, thanks for joining the session and getting back to Charlotte for the last words.
Thanks.
Yes, thank you. Last words are a few. First of all, thank you for enriching our live stream with your questions. It's very refreshing, and it's also giving this live streaming a special quality if you are engaged as you are. Still, this live streaming can only be an appetizer for Datron Next. There's so much more to know. It's all about simplicity, it's about ease of use, it's about an easy onboarding if you have used a different machine control in the past and you would like to switch. Everything is possible, as you just heard from Mark and Benny. There are many ways to transition from your previous control to Next, or maybe even use it in parallel, as our customer from Belgium did. So I'd like to encourage you to book your own live streaming, so to speak, with one of our experts, either at our Dynamics facility in the US, or maybe with our French colleagues, or maybe with our colleagues here at the HQ in Mühltal in Germany. So everything's possible. We're looking forward to seeing you again. This was one of our digital experience sessions, but of course we'd like to be more physical with you in terms of meeting you at trade shows. The pandemic is slowing down a little bit, so perhaps there is an opportunity for you to visit or to see us at the show worldwide. Just look up our sales partners online at our Datron DE web presence. This is all for now. You will get the questions and answers on our platform after this live streaming. Give us a couple of days time and you can download everything you heard today and maybe would like to watch it again or share the link for watching the recording with your colleagues and your contacts. Stay safe and we hope to see you soon. Thank you.